So now we're going to talk about prediction. So I've hit that point where I've done the hypothesis test and I found that the correlation coefficient is significant. So now what I can do is remember the example of the third exam and the final exam. Well, we found the equation of the best fit line, and now because it was a significant model, we can predict based on it. So if you see here, y hat equals negative 173.51, which is the y-intercept, plus 4.83, which is the slope. And that 73 is, suppose I want to know if you make a 73 on the third exam, what will your final exam be? So what we did is we just went ahead and put that 73 in there, and we got 179.08 because the final exam grades are out of 200. So based on the model I did, I can predict that if you get a 73 on that third exam, you'll get 179 on the final. One thing you need to be careful about is the exam scores for which were the X values for the third exam ranged between 65 and 75. I cannot predict values under that 65 or over that 75 because my range wasn't that long. Okay, so go ahead. What would you predict the final exam score for a student who scored a 66? Or what would you predict for a final score for a student who scored a 90? So what you want to do is go ahead and pause the video right now and try to solve that. Again, go back to the equation we had, put that in, and then go ahead and solve for it. All right, so what would you predict the final exam score for a student who did 66? I would get 145.27. All right, what would I get for somebody who got a 90? Well, I can't do that because remember I said my X values were between 65 and 75? But just say that you did it and you put the 90 in, you get 261.19. Well, if my final exam score can only be 200, that 261.19 falls outside the range of what my Y can be, so I can't use it. And that's another key to me that I can't make that prediction. Because even though you got a 90 on the third exam and you did great, that doesn't mean anything because my original data didn't have a 90 in it. It didn't even go up to 75. So again, this model is not good for predicting anything above 75 or below 65.